Good morning, class. So today we are going to discuss radical expressions. So let us start now from the definition of nth root. So if n is any positive integer, then the principal nth root of a is defined as follows. So the nth root of a is equal to b, means b raised to n is equal to a. If n is even, we must have a is greater than or equal to 0 and b is greater than or equal to 0. So to illustrate that one, allow me to use this one. For any real number x, the square root of x squared is equal to the absolute value of x. Why absolute value? Because it has two possible answers. We have the meaning of absolute value of x is it is equivalent to x if x is greater than or equal to 0. And the other value for the absolute value of x is negative x if x is less than 0. Now, another example, we have the square root of the square of negative 4. So, since the exponent is 2 and the index is also 2, then we can cancel 2. So, the remaining now is the absolute value of negative 4. But the absolute value of negative 4 is equal to 4. Okay, is equal to 4. I'm using here since the absolute value of negative 4 is equal to 4. Then the other example is the square root of 3 squared. So the absolute value of 3 is equal to 3. And the square root of the square of x minus 2 so is equal to the absolute value of x minus 2. And lastly, we have the square root of a raised to 4. So since the exponent is 4 and the index is 2, so write that one in terms of rational exponent or fractional exponent. So it becomes now a to the power of 4 over 2. But 4 over 2 is equal to a squared. Now, take the we have the absolute value of a squared. And the absolute value of a squared is equal to a squared. So this is just another definition of the square root, or another term for square root is the principal square root. So let a be a non-negative real number. If b squared equals a, then b is a square root of a. So the non-negative square root of a is called the principal square root of a. So the symbol of radical sign is called, this symbol is called a radical sign, is used to represent the square root of a number. So the number under the radical sign is called the radicand. Okay, an expression which comprises a radical sign and a radicand is called radical expressions. So radical expression is a combination of a radical sign with a radicand. Okay, so we have to discuss some properties of square roots. For any a is greater than or equal to 0, b is greater than or equal to 0, and n is an element of an integer. So this letter z is the symbol for integer. So this one is an element. So on property number 1, to the square root of a times b, so can be separated and written as the square root of a times square root of b. So my example for that, we have the square root of 9 times square root of 25. So we're going to separate the factors of the radicand. We have the square root of 9 times square root of 25. So take the square root of 9, that is now 3, and take the square root of 25 is 5. So multiply 3 times 5. So the answer now is 15. Okay, so another example for property number 1, we have here the square root of 2 times the square root of 8. So this is the expanded form, and then rewriting that one into a single form. So that is now the square root of 2 times 8. So multiply the radicands, square root of 16. But the square root of 16 is equal to 4. Okay. Now, property number 2, the square root of a over b. So in this case, we are going to separate the numerator and denominator with the radical sign. So the numerator now can be written as the square root of a, and the denominator is the square root of b. Take note, b is not equal to 0 or else it becomes undefined. Now, for example, for that, the square root of 49 over 4. So let us try to separate the numerator and denominator with the radical sign. So we have the square root of 49 over the square root of 4. Take the square root of 49, which is now 7, and the square root of 4 is 2. Okay? So another example, we have uh, from the expanded form writing into one radical form. So it's square root of 72 over square root of 8. So we can write that one now as a single radical. We have the square root of 72 over 8. 72 over 8 can be divided, and the quotient for that is 9. So 72 divided by 8, or 72 over 8 is 9. Now take the square root of 9, that is now equal to 3. And property number 3, we have the quantity of the square root of a to the power of n. Or we can put n inside the radical sign. So that is now the square root of a raised to n. So these two expressions are just the same. So for example, we have the square root of 2, the quantity of the square root of 2 to the power of 10 can be written as the square root of 2 raised to 10. To simplify that, in order for us to cancel the radical sign, so we factor 10 as 5 times 2, because 5 times 2 is 10. That using power to a power rule, that becomes 10. So we have now the square root of 2 raised to 5. Quantity to that is raised to the power of 2. So we can cancel the 2 here with the radical sign, because this one is just a square root. So the index is 2. So m over n, our m, it just happened that our m is equal to n. So if that's happened, we can reduce to lowest term. It's now equal to 1. So cancel that 1. So the remaining now is 2 raised to 5. So after we take the roots, you will not write anymore the radical sign after taking the roots. Okay? So some students, after they take the radical sign, they tend to write again the radical sign, which is a wrong practice. Okay? So in this case, we should write only 2 raised to 5, and you can simplify it further. We have 2 raised to 5 means 32. Okay, simplifying the square root. So we have here the square root of a squared b is equal to a times square root of b. Okay, because the square root of a squared is just a, and the remaining terms in the radical is b. So therefore, we have a mixed radical. So a squared of b is what we call as mixed radical. Okay, so if we're going to do the reverse way, if the coefficient or the whole number will be written inside the radical sign, then you just square. Look at this one. So if I have here on the right side a square root of b, if I want that to write in a pure radical, I call this one as pure radical. So the coefficient there, if you're going to write it inside the radical, then just square to that. So it becomes now square root of a squared b. Okay, so this one is a pure radical, and your answer now in terms of mixed radical. So what is the square root of 80? So what is the square root of 80? To do that, we're going to find the factors of 80, wherein one of the factors is a perfect square. So we have the square root of 80, and what are the factors of 80? That one of the factors is a perfect square. So this is now equal to square root of 16 times 5. What is 16 times 5? Is it 80? Yes, it's 80. Now, we take the square root of 16. So we have square root of 16 times the square root of 5. So square root of 16 is 4. We have 4 square root of 5. So somewhat like your A now is 4 based on this, and your B is 5. Okay? So you are going to find the factors of 80 that one of the factors is a perfect square. All right? So what about 108? So can you think of the factors of 108 wherein one of the factors is a perfect square? So we have, I guess the factor for this is the square root of 36 times 3. So 36 times 3 is 108. And 36 is a perfect square. The other one is a non-perfect square. So therefore, if we're going to simplify that one, square root of 36 times square root of 3. So square root of 36 is 6, square root of 3. Okay? What about now the square root of 1,250? What do you think now are the factors for that? So I guess the factors for this, we have the square root of 625 times 2. So 625 times 2 is 1,250. So the product of 625 times 2 is 1,250. And the square root of 625 times the square root of 2. Now, what is the square root of 625? So the square root of 625 is 25. So therefore, the final answer is 25 square root of 2. Okay, so let us evaluate the expressions. The square root of 36 over 25. So we can apply some properties here from 1 to 3. So we have square root of 36 over square root of 25. Expand it first if you like. But if you are very much aware, you can write the answers directly without using a calculator. Okay? So square root of 36 over the square root of 25. Now take the square root of 36, we have 6. And square root of 25 is 5. Okay? Now for letter B, we have square root of 50 times 2. So which property we're going to apply? I guess the number 1. So we are going to, since 50 is not a perfect square, so what I intend to do now is to multiply the radicals. But if this one of the factors here, one of the radicals is a perfect square, then I'm going to take the roots for that directly. But in this case, 50 is not a perfect square. So what I'm gonna do, multiply the radicand. So I can write now the square root of 100. And now, square root of 100 is very easy, and that is now 10. Okay? And then for letter C, the square root of 24 over 6. 24 is not a perfect square, as well as the square root of 6 is not also perfect square. So what I'm gonna do is that I'm going to write that one as one radical sign. We have 24 over 6. But what is 24 over 6? So 24 over 6 is 4, but we still have a radical sign of, we have now the square root of 4. Now take the square root of 4, which is now equals to 2. Now for letter D, which property we're going to apply? So we have just go back to the properties. So in this case, class, I'm going to rewrite this first in terms of fractional exponent. So we have 25 raised to 4 over 2. Your 4 here is the exponent, and 2 is the invisible value of n, or that is the value of the index. So simplifying that one, this becomes now 25 to the power of 2. And what is 25 squared? That is now equal to 625. Okay, so simplify each expression. Given A is greater than 0, B is less than 0, C is greater than 0, and D is greater than 0. Now, to simplify this one, the square root of A squared, B squared. So if you are now aware of the property, so we can just write answers right away. So the square root of a squared is a, and the square root of b squared is b. So simple as that. All right. And for letter B, we have the square root of 12a to a to the fifth power times b to the sixth power times c. So for start with the numerical coefficients, so 12 is not a perfect square. So we are going to find the factors of 12 that one of the factors is a perfect square. So what I'm gonna do here, class, is that I'm going to group together the perfect nth root and the non-perfect root. So I will just longer this one. So the factors of 12, we have 4 times 3. 4 times 3 is 12. All right. What are the factors of a raised to 5? That one of the factors is a perfect root and the other one is non-perfect root. So the first number that I write here is the perfect square and the other group here is non-perfect root. So the factors of a raised to 5 can be written now as a raised to 4 and a, because a raised to 4 times a is a raised to 5. Next, we have b raised to 6. So 6 there, if you're going to divide by 2 as our index, then therefore b raised to 6 gives you a whole number. Since it gives you a whole number, then it is a perfect nth root. So I just write here b raised to 6. Then where I'm going to write c? Is it in the first group or in the other group? What's the exponent of c there? So the exponent of c is just 1, right? So since 1 over 2 is not a whole number, then c must belong to this group. All right? So I'm going now to take the roots for this. What's the square root of 4? We have 2. Square root of a raised to 4 is a squared. Why is that so? So write a and divide the exponents. 4 divided by 2 is 2. Right? And for B, we have 6 divided by 2, the invisible 2 here for the index, we have now 3. Since this one is a perfect nth root, meaning to say, they are now outside the radical sign. Okay? And the remaining term will still remain as the radicand. We have the square root of 3ac. So this is now the answer for letter B. Okay, for letter C, we have the square root of 27a cubed b over 32c squared d. So the variables are different, a, b, c, and d. And we also have the numerical radicand is 27 and 32. 27 over 32 cannot be reduced to lowest term. But what are we going to do here is that we're going to find the factors of 27, wherein one of the factors is a perfect square, and also with the denominator of 32. Now, let's try to like this. So we have here the square root of factors of 27. We have 9 times 3 is 27. So how to rewrite the factors of a cubed? So we have a squared times a is a cubed. And b here, since the exponent is 1, just right here in the group of 3a. All right? And then for the denominator, we have 32. What are the factors of 32? That one of the factors is a perfect square. I guess 16 times 2. 16 times 2 is 32, and 16 has a perfect root. So I will write here 16, and the other side is 2. And then c squared, since the exponent is even number, divided by 2, will give you a whole number. So just write here c squared. And for the other variables, we have d raised to 9. So if you're going to divide 9 divided by 2, then it's not a whole number. But we can factor this one as d raised to 8 and another 1d here to make it d raised to 9. Because d raised to 8, the square root of d raised to 8, the exponent divided by the index gives you a whole number. Okay? That's why 9a squared over 16c squared d the power of 8 is a perfect root. Okay? So take now the square root for that. So what is the square root of 9a squared? We have 3a, the square root of 3ab over square root of 16c squared d to the power of 8. Square root of 16 is 4. Square root of c squared is just c. Square root of d raised to 8 is d raised to 4. Why it becomes more? Because 8 divided by 2, which is the index, gives you the exponent of 4. And then we have here, inside the radical sign becomes 2d. Or we can rewrite that one to make it beautiful. So we can write here now as 3a over 4c d raised to 4 times 3ab, the square root of 3ab over 2d. So either of the two answers are accepted. Okay, let's try to answer this. Simplifying expressions involving nth root. Because I said here nth root because as you can see, the value of the index is no longer 2. Okay, so in general, we call that one as nth root, but when it's 2, we just call that one as the square root. Okay, so when it's square root, no need to write the value of n to be written here in that symbol. Now, how to simplify this one? We have the cube root of x raised to 4. So similar also with the square root. So we can write now, we find the factors of x raised to 4, wherein one of the factors is a perfect cube. We are talking now about cube. So therefore, we can write here now as the cube root of x raised to 3 times x. Because if you're going to multiply the radicand, it will go back to the x raised to the power 4. And so, this will become the cube root of, I will just expand, the cube root of x cubed times the cube root of x. So therefore, the final answer now will give you, so the cube root of x cubed, so this will be cancel and cancel. So we just have x, and the remaining now is x times the cube root of x. So that's now the answer for number 31. Okay, now what about number 32? The fourth root of 81, x raised to 8, and y raised to 4. So we are going to express 81 in terms of fractional exponent. All right, so how would you write 81 in terms of exponent? What that is, that 3 raised to 4? What is 3 raised to 4? It's also 3 raised to 4 means 3 times 3 times 3 times 3. So 4 times, that is now 81. Correct? So therefore, we can write now as the fourth root of 3 raised to 4, x raised to 8, and y raised to 4. All right? So we take the roots now. We have, what is now the fourth root of 3 raised to 4? If I'm going to expand, it can be written in this form. We have the fourth root of 3 to the fourth power times the fourth root x times the fourth root of y to the fourth power. But if you're going to write in that way, then your solution should be longer. So to avoid that one, so just solve it mentally in this form, then we can have now the answer of, so what is now the cube root of 3 to the fourth power? So this is now, okay, this one will be the radical sign, and the exponent here will be cancelled. So the remaining there is just the radicand, which is now the whole number 3. And then this one, we have the fourth root of x to the power of 8. Solve it mentally, convert that one into fractional exponent, or simply divide the value of the exponent and the index. So 8 divided by 4 is 2. So therefore, it becomes now x squared. And this one also, y raised to 4. So 4 divided by 4 is 1. So just the remaining now is just y. So if we are going to divide this one, so we have to cancel the radical sign with that. And then that's now 1. The exponent is 1, therefore just y. In this case, we have 8 divided by 4 is 2. So the remaining exponent is 2. But we have to remove the radical sign. So that's why it becomes 3x squared y. Okay, let's proceed to addition and subtraction. Recall that a radical expression is an expression which contains a radical sign. The radicand is the number below the radical sign, or shall I say, inside the radical sign. Okay, for example, 5 is the radicand in the radical expression of the square root of 5. So 5 here is the radicand in this radical expression. Unfortunately, there is no easy way to add or subtract radical expressions with different radicands. So in other words, it is usually difficult to simplify a sum such as the square root of a plus the square root of b because the radicands are not the same. Or the difference such as the square root of a minus the square root of b if a is not equal to b. Okay, so meaning to say class, we can only add or subtract if the radicands are the same, as well as the index. If the index and the radicands are the same, then we can simply add or subtract their coefficients. Okay, so to simplify the sum of a square root of b plus c square root of b, we can apply the distributive property to the common factor of square root of b. Thus, a square root of b plus c square root of b. So as you can see here, the radicands are the same and the indices also are the same. Then we simply add their coefficients. We have the a plus c square root of b. So we cannot, but we cannot combine terms which do not have the same radicand. For example, here, we have 2 square root of 2 plus 3 square root of 3 plus 5 square root of 2. So in this case, we have the radicand of square root of 2, square root of 3, and square root of 2. So in that case, we can only add having the same radicand. So this one and this one. So add their coefficients. Take note, in adding, we only add their coefficients of the radical sign, but not the radicand. So we have 2 square root of 2 plus 5 square root of 2, whose sum for that is 7 square root of 2. We copy the common radicand. Okay? We only add their coefficients. And the other term is 3 square root of 3. Since they are not the same with the other terms, so therefore, you will just copy that term. So plus 3 square root of 3. And this will be now the final answer for adding these three terms. So we cannot simplify these expressions further. Meaning to say, that is now our final answer. Now, to determine whether or not two or more terms have the same radicand, we begin by writing each term in its simplest form. Okay? Write the expressions now in their simplest radical form. So we have 3 square root of 3 plus square root of 2 minus 5 square root of 3. So what would be now the answer for this? So we are just going to combine. So what we can combine, class, is this one because they have the same radicand. So I can write now 3 minus 5, the quantity of that, the square root of 3 plus 2. 3 minus 5 is negative 2 square root of 3 plus 2. Or you can write the answer as 2 minus positive 2, this is positive 2 minus 2 square root of 3. Take note that 2 and 2 here cannot be subtracted because 2 here is part of the mixed radical while 2 here is the whole number. So therefore, you can write the answer for this one. All right. And then for letter B, we have 5 square root of 2 minus square root of 8. So square root of 2 is already in the simplest radicand, but square root of 8 is not. So that's why we're going to simplify it first. So we have 5 square root of 2 minus, so this is now 4 times 2 equals 8. And then we have 5 square root of 2 minus the square root of 4 is 2, therefore 2. The remaining term is the square root of 2. Now it happened that they have now the same radicand and the indices, so we can simplify this one. So 5 minus 2 equals 3, and then copy the common radicand. We have now, the answer is 3 square root of 2. Okay, so the answer is 3 square root of 2. All right. Now next we have, for letter C, we have square root of 27 minus 48. So in this case, we have to simplify the square root of 27. So square root of 27 is, whose factor is 9 times 3 is 27, minus the square root of 48 can be written as 16 times 3. 16 times 3 is 48. So after that, what is the square root of 9? So square root of 9 is 3, and then the radicand now is square root of 3, or the radicand is just 3, minus square root of 16 is 4 times the square root of 3. So since the radicands are now the same, so we're going to subtract their coefficients. So 3 minus 4 is negative 1, or just write the negative of square root of 3. When it's 1, no need to write 1 because it's only one term. All right. And for letter D, we have square root of 50 plus square root of 48 minus square root of 72 plus square root of 75. So all of these are not in the simplest form, in the simplest radical form. So now let's write square root of 50 can be written as 25 times 2. That's now 50 plus square root of 48. We know it earlier. That is now 16 times 3 minus, what is the square root of 72? So we can write there 36 times 2. So we have 36 times 2 equals 72, plus the square root of 75 means 25 times 3. Okay, now take the roots. For this, we have square root of 25 is 5 square root of 2 plus square root of 16 is 4. So we have 4 square root of 3 minus, take the roots of 36, that is now 6 square root of 2 plus square root of 25 is 5. We have now 5 square root of 3. Now, by inspection, which one can we combine? Square root of 2. I have square root of 2 and square root of 2. I also have the square root of 3 and the square root of 3. So we can combine that one. So we have quantity of 5 minus 6 plus square root of 2. And then plus, in terms of square root of 3, we have 4 plus 5, then the square root of 3. So 5 minus 6 is negative 1. So just write negative square root of 2 plus 4 plus 5 is 9 square root of 3. Or you can write as 9 square root of 3 minus square root of 2. So these two answers are just the same by virtue of the commutative property. Now let's move on to multiplication and division. So to multiply or divide radical expressions, we can use the general properties of square roots. So we have square root of A times square root of B equals the square root of A times B, wherein the BA and B are inside the single radical sign. And the square root of A over the square root of B can also be written as the square root of A over B. So we can also use the distributive property of multiplication over addition and subtraction to simplify the products of expressions that contain radicals. Now let's try to evaluate each expressions. and keep your answer in radical form if necessary. So for example, letter A, 3 square root of 12 times 2 square root of 3. So how to do that? We can multiply coefficient by coefficient and radicand with a radicand. All right? So in this case, multiplying now this one, 3 times 2, we have now 6 times, multiply the radicands. We can multiply the radicands because the indices are the same. So 12 times 3 is 36. And then we have 6 times, what is the square root of 36? We have 6. Therefore, 6 times 6 equals 36. And that's the final answer for letter A. What about letter B? We have 2 plus square root of 6 times 3 square root of 2 minus 2 square root of 3. So in that case, we are going to use distributive property. Take note, this term is a binomial. We have 2 plus square root of 6, and this one also is also a binomial. Okay, so let's multiply first. First terms. We have the first term is 2 and this. These are the first term. That's for letter F. So what's the product for that? 2 times 3 square root of 2 is equal to 6 square root of 2. We have 6 square root of 2. And then for the outer terms, the outer terms is this one, that one, and that one. So we have 2 times negative 2 square root of 3, whose product is negative 4 square root of 3. We have negative 4 square root of 3. And then for the inner terms, we're using this square root of 6 times 3 square root of 2. So that is now the product of square root of 6 times 3 square root of 2 is positive 3 square root of 12. And for the last terms, so the last terms are square root of 6 and negative 2 square root of 3. So multiplying that, it gives us the product of negative 2 square root of 18. Now, after using the FOIL method, we are going to inspect which one is not yet in the simplest radical form. So I guess the square root of 2 is already simplest form. The square root of 3 is also in the simplest form, but square root of 12 and the square root of 18 can be simplified further. Now, I will just rewrite the given, the one that I'm not going to simplify it further. So I have 6 square root of 2 minus 4 square root of 3 plus, so 12 means the factors of 12 is 4 times 3. So square root of 4 is 2. Okay, I will just write so that you will not be confused. So we can write here now as 3 times 4, 3 times the square root of 4 times 3, which is now the product is 12, minus 2 times the square root of, we have 9 times 2. That is now 18. Now, we are going to rewrite first the first two terms. We have 6 square root of 2 minus 4 square root of 3 plus we have 3 times, what is the square root of 4? We have 2 times the square root of 3 minus 2 times the square root of 9 is 3. Then the remaining term is square root of 2. Now simplifying further, so we can write now 6 square root of 2 minus 4 square root of 3 plus 3 times 2 is 6. So we have 6 square root of 3 minus 2 times 3 is 6 square root of 2. Now let's combine that have the same radicand. Now let's start first with square root of 3. So square root of 3, and we have also square root of 3 here, negative 4 plus 6. We have now 2 square root of 2 square root of 3 And then in terms of square root of 2, we have 6 square root of 2 minus 6 square root of 2 is 0. Therefore, this will be cancelled and cancelled. So the final answer is just only 2 square root of 3. Okay, so for the next number, so we have 12 square root of 45. So what is the square root of 45? We have the factors of 45 is 9 times 5 is 45. So I will just rewrite first. We have 12 times 9 times 5. We have 45 minus 6 times square root of 20 can be written as 4 times 5 because 4 is a perfect square. Then divided by 3 square root of 5. So square root of 9 is 3 times 12 becomes now 36 square root of 5 minus square root of 4 is 2 times 6 we have 12 times square root of 5 divided by 3 square root of 5. Take note there is a quantity for that here. Okay, so we can simplify this one. We can combine since they have the same radicand of 5. So 36 minus 12 is 24. So we have here 24 square root of 5 divided by 3 square root of 5. We can divide this one because the radicand is the same, which is now square root of 5. So we can divide 24 divided by 3. We have now, the answer is just 8. Okay, so that's the final answer for that.